Hello everyone, and welcome back to another video where we are breaking the streak of complex analysis and doing a little bit of normal analysis. I suppose you could call it that. Anyway, we have this pretty cool integral here, and the first thing we're actually going to do to solve this is just a quick u sub. So we're going to say u is equal to x to the t. And now this might seem a little bit messy at first, but what this allows us to do is get this as just a normal 1 minus x, and then we'll be able to take this power out right there using properties of logs. So doing this, we find that du is equal to t x to the t minus 1 dt. But then also, subbing in our u's for t, we find that du over t, u to the 1 over t minus 1, is just equal to dx. I'm sorry, that should be a... Whoopsies. Okay, that should be a dx right there. Sorry. But now, doing this and plugging everything in, we find that we have... Our bounds stay the same, so we still have the integral from 0 to 1, but now we have the natural log of 1 minus u, and in the denominator, we're just going to have, well, x is just u to the 1 over t. And then for our natural log term, it's something quite similar. What we have is a natural log of u, but then we have this 1 over t term out front, and then over here we have our u to the 1 over t minus 1 du. And the nice thing about this integral actually is that these bits right here, this u to the 1 over t and u to the 1 over t, those actually cancel out. So if kind of collecting our terms, what we find is we have the integral from 0 to 1 of, and 1 over t squared on the outside, of natural log of u, natural log of 1 minus u, then divided by u itself, du. And now this integral right here, it looks quite similar to the one above, but the way we're going to solve it is actually just by exploiting the series for natural log of 1 minus u. That being, the natural log of 1 minus u is nothing but the sum from k equals 1 to infinity of sum, well, I suppose that should be u instead of x, u to the k over k, and we're also going to have a negative out front. So, using this, we have 1 over t squared, so 1 over t squared, integral 0 to 1, of u to the k, that's just going to be u to the k minus 1, and then natural log of u du. And then, of course, what I should have done is this is equal to the sum from k equals 1 to infinity of 1 over t squared. You have a k right there. I should have specified. Whenever I work on my own, sometimes I forget to write the sum down, which... That's not a good habit to get into. But to solve this integral right here, it actually isn't too awful. And we should have a negative right here, I should add. We can just say sum v is equal to the negative natural log of u. And, I mean, this integral should probably look familiar. It's going to end up turning into the gamma function. So we're just going to do, v equals negative natural log u. So dv is just equal to negative 1 over u du, but this right here is just negative e to the minus v ev. Anyway, dv equals du. I get distracted too easily doing math. Anyway, so just for the integral bit, so just focusing on this right here, we have the integral from 0, or really, what I should say is infinity to 0, of u to the... well, it's no longer u, it's e, to the minus k minus 1 v. But then we're also going to be, I do apologize, that should be a positive. Then we're also going to be multiplying by e to the v, so we can really just drop this minus 1 term right here. So that's just going to be kv. And then times, well, what is, negative right there, what is this negative natural log of u? Well, that's just going to be negative v dv. So these are actually going to cancel. And what I'm going to do is write out everything now. So we have the sum from k equals 1 to infinity of 1 over k. I'm going to put the t squared on the outside. But I'm going to use this negative that's right here. I'm just going to use that to change the bounds. So we have the integral from 0 to infinity now of e to the minus kv v dv. And then doing one more u sub. So we can do a w sub. That's always good. W equals kv. What we end up finding is that this integral bit right here is still integral from 0 to infinity, but we have e to the minus w, and then just w, and what we'll end up with is a 1 over k squared on the outside, dw. So what you'll see this integral as is just, well, gamma, or, well, I say gamma. This is really just 1 factorial, I should say. I guess technically gamma of 2, but it's 1 factorial, and that right there is just equal to 1. So what we have then, putting everything together for one last time, we have the sum, or 1 over t squared, times the sum of 1 over k to the third from k equals 1 to infinity. And you'll note that this right here is just the zeta function. So our integral right here, equal to I, is just equal to zeta of, well, 1, sorry, zeta of 3, pardon me. Zeta of 3 divided by t squared. not zeta of 1, because that's undefined, yeah, of course. Anyway, so that right there is just our answer, zeta of 3 divided by t squared. So I hope you all enjoyed this kind of short video compared to the other ones, and I hope to see you all in the next one. Thank you for watching.